The Radio Wammo Breakfast.
Live from the New Scientist Labs, Janine Young, newscientist.com.
Yes, and Janine has shifted the New Scientist Laboratories to the other side of the world for today's session. In fact, she's joining us from Scotland today. G'day there, Janine.
Good morning, Wammo. I apologise if the quality of the video is a bit ordinary or anything, but yes, we've just finished dinner and I'm on the Isle of Skye, so it could be a lot worse.
Yeah, it absolutely could be wonderful. Is the good weather there at the moment?
No, appalling. It's rained every day for the last, I think we've been here 3, 4 now. It's rained every day, but we've managed to dodge the rain every time we got out of the car. So it's actually worked out quite well. Could be a lot worse.
And a bit of sightseeing?
Yes, we spent the day today, because my other half, David, is a Scotsman, driving around various parts of the coollands he climbed here and this, that, the other. But yeah, if ever you come to the Isle of Skye, you must go to Talisker Bay. It's amazing. Black rocks is what they call a beach here. Yeah. But it's just beautiful. It was stunning. Rain absolutely everywhere. The place is always wet. I'm Australian. I find this just anathema. It's extraordinary. Yeah. But no, stunning place. Absolutely love it.
Well, even though you are on holiday, you're still on task, and we really thank you for that, for taking some time out to give us some scientific information. First up, today we're looking at whether or not you can produce fuels at the same rate as we burn them.
This is a really interesting idea. Carbon dioxide in particular is the great evil. Everybody knows. I mean, how many weeks have you and I talked about this and we've said that we have to reduce carbon emissions? Last week we were saying that none of the geoengineering options that are being played out are likely to make any difference if we don't make drastic cuts to carbon dioxide. This is starting to look at whether or not we have different ways of being able to use carbon dioxide, turning it into a fuel, for example, changing the way it's used in, say, concrete. We'll start with concrete, for example. It's actually a really good way of looking at how you can change things. Instead of using calcium carbon, I think it's calcium oxide at the moment, that's one of the main ingredients in concrete. Massive amounts of carbon dioxide are produced in the production of that every year. Yeah. What they're talking about doing now is changing to use magnesium oxide instead, which doesn't use carbon dioxide in the process, but it's able to then bind with carbon dioxide, and what it does is that it sucks it up. So you can take up to 50% more carbon dioxide in the production of that type of concrete than you do in the current production methods, which is just extraordinary, because when you think about the fact that I think it's around 70,000 of CO2 every year is produced in the production of concrete. Right. It's an extraordinary amount that's produced. I've probably got my numbers wrong on that, but the production of concrete produces vast amounts of CO2, that's the bottom line. It could be cut by a substantial amount if you're able to somehow suck the CO2 up instead of actually producing it, because it's really important in heat production and like for concrete. Other places like in the Netherlands are using carbon dioxide from power production down the road. They're taking the waste, they're putting it onto various plants and flowers, and they're making them grow a lot more quickly simply because they're using the extra carbon dioxide. Plants are particularly inefficient when it comes to using carbon dioxide. They only convert about 1% of what they come in contact with. So if you're able to somehow tweak them so that they are more effective, where you can use algae and the like to produce biofuels, there's enough can potentially start to use carbon dioxide as a fuel, as opposed to just being a waste product that you then need to try and deal with, because waste is always expensive and difficult to try and deal with. Yeah. So changing the way we think about things and changing the chemistry and the industrial processes that use carbon dioxide could potentially be really very positive for a change. Yeah,
that's it's fantastic, and obviously a lot of green tech companies are starting to look at this, and governments are starting to invest in this sort of technology as well. So it's absolutely brilliant. Let's change topic now and go to a topic I think is quite fun, because I was really into dinosaurs as a kid, and all the various names of dinosaurs and the shapes and what they look like and whatnot. But now there's some kind of disagreement in the scientific community about some of the names that have been given to dinosaurs.
Yes, potentially we could see that the name Stegosaurus could disappear. This is a terrible thing for anyone who was ever into dinosaurs when they were a kid and got to know them. Brontosaurus has already disappeared. And I must admit, I hadn't realised this. I didn't know that Brontosaurus had been taken away recently. It's all to do with something that it's actually very sad, called the Bone Wars. There were two guys that were trying desperately in the 19th century to find and name as many dinosaur skeletons as they could. And so, as happens with many rush jobs, they didn't do quite as well as they could, and instead they made mistakes. So some dinosaurs were only partially put together, and they were mislabeled as being one species when in fact they should have been something else. Recently we've also seen that Triceratops is actually, they think it's the juvenile version of Torosaurus, which is a completely, well, they thought it was a completely different dinosaur, but it's actually not. I think it's just because they were looking at them at different stages of development that, you know, you suddenly have different dinosaurs, and you don't. They're actually very, very similar. So in losing Stegosaurus, it could be that it was an incomplete skeleton that they were looking at. It is in fact another species, and so you may lose Stegosaurus. I don't actually want to say that too loud because that might upset people.
Stegosaurus was one with the big bony kind of spine down, that the protruding, and each individual sort of pieces the spine down its back, wasn't it?
Unlike every other child on the planet, I never got into dinosaurs, so I'm actually struggling, unlike my 2-year-old goddaughter, to name one dinosaur over another. So if you say that it has a spiny plate down its back, my friend, I'm going to take your word for it. That's the one specialty I just don't have.
For the next 2 minutes, I'm right. Hey,
you can be right as long as you want for as often as you want, my friend.
Hey, thanks, Janine, for joining us from the Isle of Skye there in Scotland. Where will you be next week? Goodness me.
I'll be in Glasgow next week.
Glasgow. It'll be Where in the World is Janine Young. Hey, thanks. See you next time.
See you next week.
Janine Young, of course, is from New Scientist magazine, and those stories we've just been talking about you find in New Scientist magazine, which comes out next week.